Okay, so now we're going to take the information from the actual seismogram so that we can find where the earthquake actually happened on the map. So in order to do this, we're going to take our first city. So we're going to use Oklahoma City to start off with. So the first thing I'm going to do is I'm going to take a look at the arrival time of the P wave. So all I need to do is locate the P wave on the seismogram and drop it down. So on your charts, you'll notice that the beginning time was 2:30 a.m. This P wave, if I drop this down, arrived at 2:36 a.m. and I'm going to estimate that to be about 20 seconds because it's closer to the 36. So at the bottom of my paper, the arrival of the P wave is going to be 2:36:20. So now on your papers, I'd like you to do the same thing for the S wave. What was the arrival time of the S wave? Jan?
2:39:40.
Excellent. So now I'm going to go down and record that into my table as well. 2:39:40. So now we need to find the difference in the arrival time between the P and the S waves. So I'm going to subtract the arrival time of the S wave from the arrival time of the P wave. So I'll get 20 seconds and 3 minutes. So the difference in the arrival time will be 3 minutes and 20 seconds. So now the next thing we're going to do, we're going to have to switch our papers. So I want you to take out your Earth Science reference tables and please turn to page 11. Okay, so now we have our Earth Science reference table out, and you should be looking at the earthquake P and S wave chart. So what I'm going to do, so we figured out that the difference in the arrival time between the P and the S wave was 3 minutes and 20 seconds. So I'm going to take a look, and I'm going to take my scrap piece. So everybody needs to take their scrap piece of index card, and you're going to rest it right along where it says travel time. And I'm going to take my index card, and I'm going to mark off the 0. And then I'm going to also mark off the 3 minutes and 20 second mark. So here's the 3 minutes, and here's the 3 minute 20 second mark. So I've marked both of those points on my index card. All I need to do now is slide up the index card until it matches up with the curves on the graph. So I'm going to take the bottom and keep it matched up with the P wave curve. And it looks like these match up right here. So when I read it down, okay, this line is going to indicate that the distance from the epicenter was 2,200 kilometers away. So now you're going to flip your paper one more time and you're going to pull out your map. So please take out your maps. And this is going to be the last step to figure out how to find the position of the earthquake. So down here we have our map scale. And on your map scale, you're going to take out your compass and you're going to open it up the same distance as the distance to the epicenter. So I'm going to hold one point of the compass at 0, and I'm going to open up my compass until the pencil part hits the 2,200 kilometer mark, which should be right here. So now since this was Oklahoma City, I'm going to take my compass and I'm going to put the point on Oklahoma City and draw the circle around. So now any point on this circle could be where the earthquake was. And now we need to do the exact same thing with 2 different sets of data. You're going to draw 3 circles on your paper, and where all 3 circles intersect, that point will be where the earthquake epicenter actually happened.